right, so our last segment of stoichiometry learning, we're going to still have that learning objective of using given information to convert from grams or moles of one substance to moles or grams of another substance. The last thing we're going to talk about is mass-to-mass stoichiometry. All right, so mass-to-mass or gram-to-gram stoichiometry is going to allow us to convert from mass of one substance to mass of another substance in a chemical reaction. This is going to be really important in everyday things, especially in industries and manufacturing of things such as the goods that you use, toothpaste, tires, medications. Stoichiometry is going to be used in all sorts of production things. It's going to really help companies determine the quantities of reactants they need to buy or the amount of product that they're going to be able to produce. It can also help reduce waste, which is going to keep the prices lower for consumers. So stoichiometry does really benefit us in our everyday lives. All right, so our example with this, you can see we have our equation and then the problem. First thing that I noticed, though, is that this is not a balanced chemical equation. So I'm going to have to balance this one. To do that, I'm going to start with my metal. So I see that sodium has 2 over on the right side, but only 1 on the left side. So I'd put a 2 coefficient in front of there to balance it. Then it looks like I'm going to have 2 groups of OH. Remember, OH is one of those polyatomic ions. On the other side, you don't really see an OH. However, I know that H2O, I can kind of think of it as HOH, and that's going to actually help me balance it. So I'm just going to think about it as HOH. I have 2 groups on the left side of OH, so I'm going to have 2 groups on the right side. Now, when I do that, that 2 is also going to apply to this extra hydrogen. So I have 2 extra hydrogens on the right side, and I have 2 extra hydrogens on the left side. And then last but not least, my sulfate. Remember, SO4 is a polyatomic ion, so we keep it together. It looks like I have 1 on the left side, and I also have 1 on the right side. So now we have a balanced chemical equation. Now we can go into doing our stoichiometry problem. So the question is asking, how many grams of sodium hydroxide are needed to completely react with 50 grams of sulfuric acid to form sodium sulfate and water? All right, so first thing I'm going to do is pick out my given and my wanted. So given to me in this problem is 50.0 grams of sulfuric acid. So this is going to be my given. All right, and then I am solving to figure out how many grams of sodium hydroxide I need to react with that. So it's going to, the grams of sodium hydroxide, what I'm solving for is going to be my wanted. All right, I'm going to go up to my balanced chemical equation, and I'm going to circle both of those substances. All right. For this one, we are trying to figure out how much of the other reactant we're going to need. It is still stoichiometry, though, because we're still going from one substance to another substance, or converting from one substance to another substance. All right, so this was going to be my wanted, and this is my given. Okay, so with this, I'm starting with grams of my given, so I'm starting right here, and then I'm trying to solve for grams of my wanted. So I'm ending over here. So I'm going to have to go through all of these different steps to get to grams of wanted. So I count 1, 2, 3, 4. I'm going to have 4 columns in my dimensional analysis. All right, so that kind of just like gives me an outline to make sure that I am doing this correctly. I should have 4 different columns to solve for this problem. So the first thing that I'm going to do, I am in grams of sulfuric acid. That's my given. So I'm going to put it in my upper left-hand corner. Okay, so I'm starting here. To get to the moles of that same substance, I'm going to have to go through our molar mass equal statement, or look at your periodic table to figure out what the molar mass is. Keep in mind that it's always going to be equal to 1 mole of the substance. So I can make an equal statement saying 1 mole of H H2SO4. And then you're going to look at your periodic table. You're going to add together 2 hydrogens, 1 sulfur, and 4 oxygens. When you add those up, you should get 98.086, and that's going to be grams of H2SO4. All right, and then I'm going to have to figure out how I'm going to put this into my dimensional analysis grid. So I'm going to put it in that second column. I have grams of H2SO4 up here, which means that I'm going to have grams of H2SO4 on the bottom. So my 98.086 grams of H2SO4 would go here, and I know that's going to be equal to 1 mole of H2SO4. Okay, so my grams of H2SO4 cancel. My next step, I have to go from moles of the given substance to moles of the wanted substance. Okay, so when I'm going from one substance to another substance, the only way that I can do that is to look at my balanced chemical equation and find my mole ratio. So looking at my balanced chemical equation, I'm going to make that ratio or that comparison between the two different substances. So I see that I have 2 moles of NaOH, and that's going to be equal to 1 mole of H2SO4. All right, once again, my next column, I have to figure out which goes on top, which goes on the bottom. I know that I want my moles of H2SO4 to cancel, so I'll put that on the bottom, and then my 2 moles of NaOH. There really shouldn't be any parentheses there, sorry. Pretend I didn't do that. All right, so my moles of H2SO4 cancel. Now I'm going to be in moles of NaOH. And then my last step, I don't want to stop at moles this time. I'm going to go to grams. So my last step is going here to the grams of the wanted. And here again, we're going to use a molar mass equals statement, and we're going to look at our periodic table to determine what is the mass of NaOH. So remember that molar mass equals statement, it's always going to be 1 mole of the substance, and then you calculate what that molar mass is. All right, when you add those up in your calculator using your periodic table, you should get that 1 mole of NaOH is equal to 39.998 grams of NaOH. All right, last step, we have to figure out which one goes on top, which one goes on bottom in that last column. I know that I want my moles of NaOH to cancel, so I would put the 1 mole of NaOH over here and my 39.998 grams of NaOH up top. All right, so my moles will cancel. Now I need to calculate everything, multiply everything on the top, divide by everything on the bottom. So 50 times 2 times 39.998 divided by 98.086. All right, and if you do that in your calculator, you should get 40.7785, some more numbers. I'm going to round to the 10th place this time, so I would do 40.8 grams of NaOH. So if I want 50 grams of sulfuric acid to react completely, I'm going to have to make sure that I get 40.8 grams of NaOH so that all of that stuff can be used up to make my products. All right, at this point, if you have any questions, I can definitely go through some more examples with you. However, with gram to gram, it's really going to keep being the same setup. So you're starting with grams you're given, you're ending with grams of your wanted. It's kind of different than that mole to gram or gram to mole. You really got to read and see what you're starting with and what you're trying to get to. I feel like gram to gram is the easiest for a lot of students, so hopefully you guys do all right on this. Just make sure that you reach out if you have any questions.